Now we're down to the last of the 4 small lectures. Now we'll look at what does Cisco do? What does a switch do to forward information? Okay, yeah, it's one thing we know that the 2 major functions that's done with the MAC address is what? Store and forward. So I got to store the information, I got to forward it. But the question is what's the best way to do this? What is other ways that switches use to store information and forward it, packet on to others? Now there's 2 major methods to transfer data between network ports. One is stored and forward switching, and the other one is cut-through switching. Now, store and forward switching, basically, it receives the entire frame, computes the CRC. If the CRC matches, then it goes through fine. But that's processing a lot of information on every single frame. The other one is called cut-through switching. Now, cut-through switching says, I'm forwarding frames before it's entirely received. So I may only received enough. I may just receive enough to process the source and destination MAC address. I think it's a little bit longer than that, but I need to have that much information. I need to have about 64 bits of information to know that I'm sending it. Now, why would I do that? Well, based on what quality of service you want things to run through as fast as possible. Now, if you want guaranteed delivery of service, you're going to want to make sure that you're doing a store and forward method. In some cases, you don't care as much. You're more worried about speed than accuracy, and there'll be other ways of correcting it. Then you can say, hey, I'm going to just do the cut-through method. So watch the video, see how the store and forward works, but it basically means I'll process and everything, run the CRC before I make a decision what I'm doing with it. The cut-through method says, hey, all I need to do is a small part of information. Even if the transmission is not complete, I'll buffer, just enough data to read the destination MAC address to determine that the port, what am I doing with it? Is it on the same switch? Am I forwarding to someplace else? So it basically says I got the first 6 bytes and the destination MAC address have to be available to me to be able to read it. Now, of course, I'm hoping that it's guaranteed that it works, but I think you need to think about, so that means I don't have to process all 1,500 bytes of information and run the CRC, so it's definitely a time saver. And there's a couple of variants to this cut-through. One is fast forwarding. Basically, it's the lowest level of latency. It's the fastest out there, only because it starts forwarding the information before the whole packet's been received. And there, of course, there are many times that faulty packets arrive, but that's the fastest way. Then the other one is fragment-free. Now, fragment-free switching says, I'm going to store the first 64 bytes of the frame before forwarding. So it tries to make sure there's more information available. And once it gets to 64, it's pretty much, it's got valid address, it's got preambles correct. So it tries to, give you the best of both worlds a little bit. Now, some switches are configured for cut-through on a per-port basis until you define it to do something else. So it just depends on your switch, and we'll do some labs maybe a little bit later as far as how to set some of these parameters up. So just know right now there are several different ways of doing this now, because every one of your switches have memory. They got buffer that is storing information. Now, there's a couple of different types of memory. There's port-based memory, which says, hey, what I am storing in queues. I'm putting things together in a list that for specific incoming and outgoing ports. And the frame is transmitted to an outgoing port only when the frames ahead of the queue have been successfully transmitted. So I'm not going to send anything out until everything ahead of me, so the person in the line in front of you is done, then I'll go ahead and try this. Because it's possible to have a single frame delay. In some cases, you can wait. Some devices have shared memory, and all the frames from all the ports are put in this memory in the buffer. That's dynamically allocated at runtime. And everybody is, the frames in the buffer are dynamically linked to the destination port so that I don't have to do a lot of movement in and out of the canoe. So every frame comes in, it gets dynamic linked to this, so there's no movement of data within a buffer queue or anything of that nature. So shared memory ability stores larger frames, potentially fewer drop frames because I'm not moving them around as much. So, and of course, this is pretty important when you're doing asymmetrical switching. Different data rates, different ports. So as we get into faster and more enhanced switches, that shared memory becomes pretty important. Now, since we're going between two different ports, two different physical devices, sometimes the two most important settings is what's the speed am I communicating in, and what duplex am I setting at? Basically, how am I communicating between two devices? Is it a one-way communication, which is half duplex, or is it full duplex that both connections can send and receive simultaneously? So this is part of the negotiation that takes place when each device gets plugged in, is what's my speed am I communicating at, and what's a duplex? Is it full or half? Because you may see a test question if the duplex, if one end is full and one end is half duplex, the two devices cannot talk together. So the duplex must match. I don't care if it's half and half, full and full, they have to match. Otherwise, communication will not take place between the two devices. And you can go through the different negotiations of speeds. Now, what usually happens in most newer devices is there's an auto negotiation, auto MDIX, it's called. And basically, once its system first comes up, it negotiates this, and it decides how it's going to, what speed it's going to run at, and what duplex. So if you're using a newer switch, this may already be determined for you, but I can guarantee you probably will see a lab later that you have to set the speed and the duplex. And I didn't have you do a packet tracer lab on that, but just know that duplex mismatches occur on a link. Now, it just says, hey, so just know that auto MDIX kind of negotiates the speed and the duplex so you don't have to manually set it. So I think, nope, I guess that's a little bit more. Now, which does come into play when you've got cabling issues. How to pay attention to this. Usually the device is, if it's a like device, you need a crossover. If it's so you see I got switches on both sides, like devices, doing the same function, I need a crossover cable. Why? Because now I got these 8 wires. and I'm communicating and receiving on two different wires, and if I can't communicate on the same wire, so somebody's got to flip which way they're sending and receiving on wire. If they're dissimilar devices, a switch and a router, I can use a straight through. I don't have to do any changes. Same thing with PCs to a switch, I can use a straight through. Now a PC to a router, since a PC basically does routing, it makes decisions on where data is sent, it performs the same function, so you need a crossover cable to connect directly to a router. But Auto MDIX takes some of this stuff out of your play, but you can pretty much guarantee that those wiring connections between those devices you will see again. So go ahead and take the quiz, and I think that is it as far as my lectures are concerned on Ethernet switching. Hopefully it helped. If you have any questions, let me know. Talk to you later. Bye-bye.